Hello, my name is Seth. I'm an instructor here at Test Crackers, and thank you for inviting me onto your screen. I'm here to help you out with what I think are 10 of the toughest problem-solving problems in the official guide to the GMAT. I'm doing this because I get a lot of questions on these questions from my students, and because I think they're good examples of a lot of the tools that can help you with all kinds of GMAT problems. But I have to give you two caveats to begin with. Number one, your score is probably not being held back by the 10 toughest problems in the official guide to the GMAT. It is easier problems than these ones that are in most cases holding you back. And if you want more on strategy, check out our other videos and check out our Test Crackers courses. We've got a lot of tips for you there. Number two, everybody is going to have a different way of approaching problems, is going to have different things that come most easily to you. And so I don't want to assume that what I'm doing here is best for everybody, but what I do feel comfortable saying is that the tools I'm using here are tools that you should try out and become familiar with. Because if not for this problem, there are other problems that you're going to want to use these types of tools on, and so they should be useful things for you to have. All right, with that in mind, let's check out one of these. During a trip, Francine traveled X% of the total distance at an average speed of 40 miles an hour, and the rest of the distance at an average speed of 60 miles per hour. In terms of X, what was Francine's average speed for the entire trip? Our first read is just about getting the lay of the land and understanding what hints there are in the question that tell us the kind of structure or approach to use. Don't worry about starting to do math on that first read through. Worry about just thinking, what's the point? What am I working towards? And what tools am I going to use? Start with the question. What are we being asked for? Average speed. And you might write that just so that you have that in mind. You don't forget it. Next thing, we've got distances, we've got speeds, we've got Francine, we've got a variable, X%. All those things matter here. And so you need a tool for dealing with work rate problems, which this fundamentally is. You might have all kinds of things. The one I like is what's called a work or distance T. This is something we use at Test Crackers. It goes with the idea that work equals rate times time, and just the same way, distance equals rate times time. And so you could write that out as a formula, distance equals rate times time. You could name all those variables and you could make all kinds of equations with them. I want to minimize variables. It's one of my goals in every math problem. So here, rather than writing them out, I'm just going to draw a T. And I'm going to say, I know that it's distance, rate, and time. So by positioning things, I can sort of see visually all the data that I've got, and I know those relationships. Because I know distance equals rate times time, and I know this works kind of like a fraction line. So you can think about rate as equaling distance over time, or time as equaling distance over rate. These are just the algebraic transformations here, right? Rate equals distance divided by time, and time equals distance divided by rate. All of those three formulas are kind of in mind, and all those three variables are in mind if you just use a T. So we're going to set up a T here. We're going to say, well, what do we know? What information goes into this? I see a rate, 40 miles per hour, so I want that in there. And then later I see another rate, so that's going to be in a different T, 60 miles per hour. Francine is traveling X% of the total distance at this rate, and the rest of it at this rate. Now in terms of X, I could set up an algebra problem now by writing this, 100, some fraction and all the other pieces, 100 minus X. I don't want to do that. I want to make my life easy. So the first tip is, because it says in terms of X, because X appears in all of the answer choices, and because I want to avoid algebra, I'm just going to say X equals 50. And this is a smart choice, I find, when you've got a percent that you're making up, like X% of the total distance, because 50-50 is an easy split. It's half. It's just cutting things in half, and because 50 is a pretty easy number to work with, as we'll see later. So I decide, okay, she traveled half the distance at this speed, half the distance at the other speed. Next issue, how far is she actually going? Well, they don't tell us. And so I could make up another variable, y or something, for what the total distance is, and that'll work, and there's a way it would cancel out. I don't want to go down that road either, because I've learned from GMAT problems, when there's an unknown total, like an unknown total distance, we can make up that distance with some simple value just to make our lives easy. So rather than putting a variable in, let's just say, what would be nice numbers to work with? if we're going to put half the trip here and half the trip here, well, I've told you that time equals distance divided by rate. T equals d over r. So if I'm working towards getting a time for each of these, I'm going to make up a distance that's going to be easy to divide by 40 and by 60. First number that comes to mind for me is 120. And so if 120 miles is half the trip, then 120 miles is the other half of the trip, and then I'm going to be able to do some relatively simple division. It's worth making a point here. You, at home, are a real human being. And so when I choose 120, I am prioritizing you and trying to make your life easy over Francine. Francine is not a real human being. Somebody who works for GMAT made up Francine. It is a figment of that person's imagination that we're dealing with. And so we don't need to worry about whether 120 is convenient for her. I'm sure Francine would prefer that this were a much shorter trip and that she didn't have to drive 240 miles, but I'm not worried about Francine, I'm worried about you. And I want you to take the same approach when you make up totals. Your priority in making up totals is always yourself, and is always just saying you want to make life easy for you. You want the number that's good to work with. And if the first thing you have to do is divide by 40, then you want a number that's easily divisible by 40 and will give you a nice answer like 3, or in this case, a nice answer like 2. If we had made up some other number, if we're like, oh, Francine really shouldn't have to go that far, let's just say it was like 5 miles there and 5 miles back. First thing I have to do is divide 5 by 40. Then I have to divide 5 by 60. That sounds annoying to me. I have no interest in that. So I do not care about how far Francine has to travel. At this point, we filled in our t's. And so we've mapped out a scenario including everything involved in a trip. We've got a distance, a rate, and a time. Now we just need to answer the question, what was the average speed? There are a lot of ways you can come up with this. One thing to know, though, is it's not going to be halfway between 40 and 60. In reality, that's because it's a weighted average, and that's an issue I'll cover more in other questions. But in terms of this, the best way to think about it is just to say average speed has a simple equation, and it's one of the simple equations worth memorizing for the GMAT. Average speed equals total distance over total time, and it would have been great to even start off by writing that. If we saw the question was fundamentally asking for there, then we'd know our whole goal is just to come up with a total distance and a total time. And with this chart, we now have done that. Total distance is going to be 120 plus 120 equals 240. And total time is going to be 3 hours plus 2 hours is going to equal 5 hours. So now we know 240 miles divided by 5 hours, that's going to get us our average speed. Problem is, some of you might not be thrilled about dividing 240 by 5. So I have to bring in another tool. It's called how to divide by 5. Divided by 5 is the same thing as multiplying by 1/5. That's just basic fraction rule, because if we've got a denominator, we're dividing. But we could multiply that by 2 over 2 to get something even easier to work with. 2 times 1 is 2, 2 times 5 is 10. So dividing by 5 is really the same thing as multiplying by 2/10. And that's very easy to do. Take this example, 240. If we're multiplying that by 2/10, we can say, well, the 10 cancels out there, and then we just have 24 times 2 is 48, and that's our answer. 48 miles per hour. We've come up with a target for what we want the answer to be if we're going to assume that x is 50. And that's a big if, it's a key if. This is the key to using a made-up value for variables. You say, let's not worry about having an answer in terms of x. Let's just come up with an answer when x is made up as an easy value. And so now we know, put 50 in, we should get 48 out. We're ready to look at answer choices and find a match. So let's go through those 5 answer choices, starting with answer choice A. And answer choice A says 180 minus x, so in this case minus 50, all over 2. Okay, this is not 48. And we could solve for it, and I will, but I hope sometimes you're going to be able to spot things that just can't work out. So think about that. Why is it that this can't be 48? Well, for one, it's not going to end in an 8. For 2, we could say it's 130 over 2. And so we could realize 2 divided by 0 is going to end in a 5. We could realize if we were going to get 48, we'd need to have double 48 up here. It's going to be less than 100. This is too big. 130 is not the number we want there. Or we could actually just calculate it and say, this is the same as 100 over 2 plus 30 over 2, which is the same as 50 plus 15, which is, of course, 65, which is not what we're looking for. It's not answer choice A. Forget about answer choice A. It's out of the running. And that's the thing I really like about this technique. It guarantees something is not the answer if it produces the wrong result. B, x plus 60 over 4. So 50 plus 60 over 4 is going to be 110 over 4. Once again, I can tell you pretty quickly that's not 48. And I can tell because 0 divided by 4 won't produce an 8. I can tell you because it's too small. This is going to be more like 28 or something. And I can tell you because 100 over 4 is 25, plus 10 over 4 is 2.5, and so it's going to be 27.5. Choice C. What do we get there? 300 minus x over 5. 300 minus 50 over 5. Well, that's going to be the same as 250 over 5. And potentially the easiest way to do this one is just to do the math. That's going to be 50. You could tell, once again, the ones digits aren't going to align. You could tell that 50 is close, but close is not really what we're looking for here. Vitek is not an approximation strategy where we make up variable values. This is an answer strategy. And so the fact that 50 is close to 48 is about as worthless as things can get. Let's try D. 600 over 115 minus x. In this case, 115 minus 50. This is also not going to work for us. And I can tell because it's not the right size approximately. I can tell because if we just calculate this out, 600 over 65 is going to be closer to 10 than it is to 48. I can tell because we could actually get a value here. Either way, it's not our answer. So we're down to E. And if you believe everything we've done, then E's got to be it. E's got to be it, just through process of elimination. But if you're not sure, if you want to be safe, let's go ahead and do the math. 12,000 all over x plus 200, or 50 plus 200. Okay, so this is going to be 250 on the bottom. And we can easily lose a 0. Divide both of these by 10. But we're left with 1,200 over 25. Some of you might not be super comfortable doing that math, so I'd invite you in that case to multiply the whole thing by 4 over 4. You're always trying to mess with place value. You're trying to deal with zeros. That's the heart of this trick about dividing by 5, is that dividing by 5 seems hard, dividing by 10 is easy. And if we multiply 25 by 4, we get that same benefit. On the top, we'll get 4 times 12, 48. The zeros stick around for 4,800. 4 times 25 is 100. Now we've got something that can easily reduce. Lose those zeros. You've got 48 over 1, or just 48, or exactly the match for what our target was in the beginning, and therefore this is it. There's a way to algebraically get this, and to say 12,000 over x plus 200 is going to give us the average speed for any value for x. And it's great to know that. Some of you might even think that's an easier way to do this problem, but I'd say try it both ways. And you'll find, a lot of you, that that isn't an easier way to do the problem. And once again, even if you do, you'll find that the tools I used here on some problems are going to make your life easy. So let's look at this and let's recap a little, talk about the tools we've got in mind. First thing to note, read the problem and try and understand the categories. In this case, we saw, okay, this is asking us for average speed. And so write down what the question is, and even write a formula. Total distance over total time. And there you go, that's one formula that's worth remembering because it shows up on the GMAT and it'll guide you well. Second thing is organization. Right? Learn tools, whether they're tables or T-charts or whatever, to set up your problem. And in this case, we said, oh, this is a rate problem, and specifically a distance problem. So let's use the work rate T, because work equals rate times time, and distance equals rate times time. So find a structure. Step 3, make up a total. If there's a total and it's not mentioned, there are a lot of times where you can just make up a total because the answers are just fractions or percentages or in other ways functions of that total. This happens a lot in work rate problems. It's going to make things easy. And tool 4 or step 4, make up a variable. If the variable shows up in the answer choices, you can make up that variable and you can just check them for a match. We also talked about the idea of dividing by 5. Dividing by 5 equals multiplying by 2/10. And all of these are tools that you might want to use other places. Hope that's been helpful to you. Check out our channel. We've got a lot of other videos, and I'll be making more of these as I run through the 10 toughest problems in the latest official guide. Like, subscribe so you can keep up on those. If you want to check out our Test Crackers classes, we run small group classes all the time, live online through the internet, highly interactive. And in those, we're going to go in-depth in strategies for all the types of problems you're going to see on the exam. We're going to be there, more importantly, to answer your questions and give you feedback and advice as you work through and try to apply these on the questions that you see in the homework. So please do check those out. We've got a bunch of links below, and you can use those to find out more about Test Crackers and what we offer there, or just check out these other videos for more help on my 10 Toughest Problems series. All right, thank you.